a descriptive language. So for the circle, I'm just going to kind of draw this is the mathematical cone, right? Kind of, it looks like two cones on top of each other, but they're just calling this a mathematical cone. So how would you describe? You have to slice the cone how? Yeah, horizontally, or you could say parallel to the base, couldn't you? Isn't that line going to be parallel to the base? So parallel to the base. And then what about to get an ellipse? So if I try to slice it again, kind of here's my cone. How am I slicing it? How am I slicing it to get an ellipse? Yep, diagonally and not through the base, right? Because if you start going through the base, you get like that flat part at the bottom of the parabola or hyperbola, right? So I would say that it's diagonally and not through the base. All right, so the hyperbola, this one, what word did you use, Kyle? I heard you say it. Yeah, so vertically, because that's how you're going to cut the top and the bottom part of the cone. So could you also say that it's like perpendicular maybe? Does it have to be completely perpendicular though? It doesn't, does it? Because if I go a little bit this way, I'll still hit both of them, won't I? So we'll say, we'll just say vertically. And we'll say through both of the bases, right? Right? I think of it as vertically though. So then how do you slice it to get the parabola? This is when you only want to cut one of the two cones. So see how if I put a line like that, I will get that half arc, but I'm not going to touch the bottom cone, so there's only going to be one of them. So it's actually diagonally again, but you're going through one of the bases, right? Diagonally through one base. This isn't really any official language, just thinking about, okay, I've got the same shape that I'm starting with. How do I generate these four different things? We're going to come up with these formal definitions kind of each time we start one of the new shapes, but we're starting with circle. It's a set of points that are all equidistant from a fixed point called the center. So we'll come back to these other definitions and I'll show you what they mean later. Right now they just kind of look like jumbled words, right? A set of points, the sum of the differences from two fixed points called foci is constant. Like we're going to see what that actually means when we study ellipses. So for now, just the big idea of what are the four that we're studying and how do you cut a mathematical cone to generate them, right? Remember they went like this, and this, and they like drew a circle, and drew like a circle or something. So they defined like the one intersection point of the three circles. So it took 3 guesses. So on a flat plane, we just said it takes 3 guesses, but why does it take 4 satellites? So Earth is curved, right? And so when the 4 satellites are in space, what shape were they drawing around each of those satellites? Was it just a circle? It was a sphere. So to find the intersection point, they needed 4 because it was the 4 spheres and where they intersected because the Earth is curved, right? So it's not just on that flat surface, you're just drawing a circle like on that map. It was the intersection of 4 spheres. He was showing you that in the video. And then something else interesting about a real life conic application, I don't know, maybe you look around you and see like the architecture now and, you know, even in our auditorium. Has anyone stood in the U.S. Capitol? In the domed room? Anyone taken a tour of the U.S. Capitol in D.C.? So there's the echo chamber there. And there's a story, right, in the old House of Representatives that so-and-so's desk was on one point and the other, and so they could overhear conversations from the other party. I don't know that exact story, but we'll talk about echo chambers when we talk about ellipses, because it's an elliptical ceiling that will do that. So I just wanted to take a few minutes and just introduce the circle to you, and then we'll practice with the circle next time because we won't have a lot of time today. But if we were going to draw a circle that has a center at the origin and a radius of 5, So here's our center. I'm just going to go 5 units out. 1, 2, 3, 4, 5. You don't have to use a compass, but 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So just kind of estimate, you know, here's my circle. Who can draw the best circle in here? It's not me. So there's my circle with a radius of 5. It said mark point P somewhere on the circle. So I'm just going to make this point P, right? I'm going to call that X comma Y. So that way P could be anywhere, right? It doesn't have to be at that specific coordinate on the circle. So they want us to write an expression for the distance between point P and the center of the circle, right? How can I write that as a distance formula? Do you remember the distance formula from geometry? Basically, you're using a right triangle, right, to figure out the distance formula because you're using the Pythagorean theorem. So what's this distance? This is just x. What's this distance? This is just y. The Pythagorean theorem says x squared plus y squared will give you your distance squared. Do you remember that from geometry? So because this is centered at the origin, I know that this is x minus 0, so this has a length of x. This has a length of y. So it says write an expression for the distance between point P and the center of the circle. Isn't it the square root of x squared plus y squared, right? Because that would give me distance squared, and I'd have to take the square root of it. That's the Pythagorean theorem, right? Leg squared plus leg squared equals hypotenuse squared. So if I take the square root of it, I'd have the distance of that hypotenuse. And it says, since you know the radius of the circle, you can turn your expression into an equation that would describe all points on this circle. So we know that our radius is 5, right? So we can say that the square root of x squared plus y squared is always 5. And the more common way to write the equation is that x squared plus y squared equals 25. So for any circle, we're going to see that r squared is always going to be on the right-hand side of the equation. So this equation has a center at 0, 0 and a radius of 5. It has a plus sign between x squared and y squared. That's how you know it's a circle. So let's move our circle on the next page. So now what happens if our circle is slightly off from the center? So it says, what's going to change? Let's draw a circle this time. And if you notice, the origin is kind of down here. It's supposed to be bolded. But if our center is at 1, 2, 3, 1, 2, 3, 4, 5. So here's our center. And they want to do a radius of 4 units this time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So how can I write the equation for this circle? So we're going to use the distance formula to create an equation for this circle. I'm going to call this point P again, and I'm still going to call this point X comma Y on my circle. So this is going to be any point on the circle. How can I generate an equation? So how does it change this time? I still want to find this distance using the Pythagorean theorem. So what is this distance? This distance is no longer x, right? Because I'm not starting at 0. This distance is really x minus, didn't this have, I was over 3, right? So whatever this x value is, right? If I subtract 3, I'll know this distance. So this has a distance of x minus 3 because I'm 3 units over from 0. So I don't want to count these 3 units over here. And then this would be y minus 5, right? Because I don't want to count this extra 5 units. I just want this dark spot. So this is y minus 5. So the distance is x minus 3 squared plus y minus 5 squared to give me this distance again. So I'm going to call it d squared this time. I'm going to say x minus 3 squared plus y minus 5 squared equals just my distance squared that I'm looking for. So I'm going to call this d. We know that this is going to end up being r, the radius of our circle. But if I was just using the distance formula, would you agree with me? Leg squared plus leg squared is the hypotenuse squared. And then it says we know that the hypotenuse, the radius was 4. So the exact distance is 4. So we could just rewrite this, x minus 3 squared for our circle plus y minus 5 squared is always going to be equal to 16, because 4 squared is 16. And we're going to practice with this equation tomorrow, but remember vertex form, x minus 3 goes to the right when it's inside the parentheses. Well, now the y is also in parentheses. So when it's y minus 5, y is going to go up 5. If it goes down, it would be a plus sign because it's inside parentheses now, and then this is always your radius squared. So the general equation for any circle, x minus h squared plus y minus k squared equals r squared. So h comma k is the center and r is the radius. And so this formula you're going to get really familiar with tomorrow because we're going to use it a bunch to graph a bunch of circles. And you might not be able to do the circle homework yet because tomorrow we're going to look at when you get a kind of an equation that looks like this, right? I can't graph that. I need to learn how to convert that equation to look like this. So you might have to hold off on the homework until we do that tomorrow.